Here slip is nothing but difference between the synchronous speed and the rotor speed is called slip. Slip here, that's nothing but the difference between the synchronous speed and the rotor speed. You know well, the speed of the synchronous speed is nothing but ns. I mean, speed of the rotating magnetic field is called ns. In a stator winding, in a stator, the field is rotating at a synchronous speed. Am I right or not? In a stator winding, the field rotates at synchronous speed. Ns is equal to 120 F by P. Ns is equal to 120 F by P. So according to the poles and according to the frequency, this stator winding magnetic field is rotating at synchronous speed. Ns. Am I right? So that is fixed. According to the frequency and according to the poles, this speed of the rotating magnetic field is changing. Okay, frequency is constant in our India, that is called 50 Hz, and also poles means at a design stage only the poles are changing. Once a machine is designed completed, once machine is designed, the poles are fixed. Am I right or not? Once machine is designed, okay, the poles are fixed. Poles are 2 or 4, so whatever maybe. Once machine is designed means the poles are constant, so the frequency is also constant. That means stator rotating magnetic field is constant. But rotor speed is so according to the load, the rotor speed is changes. Am I right or not? According to the load, the rotor speed is changes. Understood? When load is increasing, so what happens? The speed of the rotor is decreasing. You know when? Okay, this load is increasing means speed of the motor is decreasing. When load is decreasing, speed of the motor is increases. Based on load, rotor speed is changes. Okay, but the stator's rotating magnetic field is constant. That is called synchronous speed. Stator rotating magnetic field is constant always. Okay, but rotor speed is different. So the difference between the stator rotating magnetic field and the rotor speed is called ns minus nr is called slip. Okay. So here we have seen above that rotor rapidly accelerates in the direction of rotating magnetic field. Okay, when we are giving the power supply to the stator winding, and then the rotor rotating magnetic field is developed and is rotating, accelerating in stator winding. Okay, according to the phase sequence, understood. Accelerate in the direction of the rotating magnetic field. Rotor rapidly accelerate in the direction of the rotating magnetic field according to the Faraday's law and Lorentz force. Okay, in practice, this rotor can never reach the speed of the stator flux. Am I right or not? The rotor speed is not equal to the synchronous speed. In an induction machine, the rotor speed is not equal to the synchronous speed. If the stator rotating magnetic field and rotor is rotating in same speed, so what happened? There is no difference between the stator and rotor. Am I right? There is no relative speed between stator and rotor. That's why the EMF induced in the rotor is equal to 0. And current is equal to 0. The torque, the force is 0. Then there is no torque developed on the rotor. Understood? If the stator rotating magnetic field and rotor is rotating same speed, that's why the rotor always less than the synchronous speed in induction machine. Okay, the rotor can never reach the speed of the stator flux. That is called stator rotating magnetic field. Okay, if it did, okay, there would be no relative speed between stator field and rotor conductors. Am I right? For example, if the stator rotating magnetic field and rotor is rotating at the same speed, that means there is no relative speed between these two, and no induced rotor currents, and therefore no torque to drive the rotor. Am I right? Okay, the friction and windage would immediately cause the rotor to slow down. Okay, because of the friction and windage effect on the rotor, immediately the rotor speed is slowed down. Hence, the rotor speed n this is called rotor speed notation n or n suffix r. Otherwise, n suffix r. Otherwise, n only. The rotor speed is n is always less than the suitor field speed of ns. Okay, the rotor speed is always less than the synchronous speed ns. That's why the rotor speed is always less than the synchronous speed. The rotor never reaches the synchronous speed because of friction and windage losses. Understood? If it is rotor is rotating at synchronous speed, if the rotor is rotating at synchronous speed, EMF induced in the rotor 0 and current 0, force 0. There is no torque developed on the rotor. Am I right? So there is no torque developed in the motor means this frictional and windage loss effects coming to the rotor, and the rotor speed is reduces below the synchronous speed. Okay, and then there is a this is called there is a speed difference between stator and rotor field is existing. Stator rotating magnetic field, and rotor, there is a speed difference is exist. That is called slip. The difference in speed depends upon the load on the motor. Am I right? The difference in speed is depend on load on the motor. The load is increasing, speed decreases. The load is decreasing, speed increases, but never reaches to synchronous speed. Nowhere reaches to synchronous speed. Understood? The difference between the synchronous speed ns and rotate, the difference between the synchronous speed ns of the rotating stator field and the actual speed ns is called slip. The difference between the synchronous speed ns of the rotating stator field and the actual rotor speed n is called slip. That is called ns minus n. Okay, it is usually expressed in percentage of synchronous speed. That is called percentage of slip is equal to s is equal to ns minus n divided by ns into 100. Here n is called rotor speed. Okay, so for simplicity, so we want to take n suffix r also valid. So some books are taken notation like this. So ns minus nr divided by ns. Percentage slip is equal to ns minus nr divided by ns into 100. Understood? So here the quantity ns minus nr is sometimes called a slip speed. Remember, some of the problems is asked like this: find the slip speed. So what do you have to do? Find ns minus n. So then that is called a slip speed. Okay, the quantity ns minus n is sometimes is called as a slip speed, and then when the rotor is stationary, that is called n is equal to 0 now. When rotor is stationary, that is called speed of the rotor is equal to 0. This is called rotor speed. When rotor speed is stationary, that is called n is equal to 0. If n is equal to 0, then what is the slip here? Slip is equal to 1. Am I right? Ns by ns. So if it is rotor speed n is equal to 0, means ns by ns, that is called 100%. Slip is equal to 1 or 100%. At starting condition, the rotor speed is equal to 0, then slip is equal to 1. In an induction motor, the change in slip from no load to full load is hardly 0.1% to 3%. Maximum the percentage of slip in induction motor is 0.1% to 3%, so that it is essentially a constant speed motor. Essentially a constant speed motor. Generally, the induction machine is called as a constant speed motor. So because of the slip is changing from 0.1% to 3%. Understood? This is about slip concept.